Okay, let's look at ceramic density calculations. They're going to be very much the same as what we did for metals, except we've got more than one type of element. We've got an anion and a cation. Um, all right, so let's take a look at that, and we're going to look at rock salt. Okay, so we've got a cube. We're going to position some anions in the FCC type positions. Okay, and then we're going to see nestled in amongst them in these little interstitial sites are these cations. Okay, and so now if we want to calculate the density, well, all we need to do is add up the number of atoms of each type, how much they weigh, and divide by the volume, just like we did for a metal. So the only difference is you'd have the number of cations times the atomic weight of the cation plus the number of anions times the atomic weight of the anion in the numerator, instead of just having one type of atom. And then in the denominator, again, we have the volume of the unit cell and Avogadro's number to make sure that the units work out. Okay, so that really is it. The only adjustment is to the numerator, where we've accounted for both the cations and the anions. Okay, and that's the anions there, anions. So, for example, if we were to work this out, just initially for rock salt, okay, just really quick, you could actually add them all up. You got 1/8 at each corner times 8 corners plus the 6 faces at a half of an atom each. We're going to have 4 n of the anion is equal to 4, and then cations. Well, you got the 12 edge positions. Each one is a quarter, so that's 3 plus the one in the very center, and completely there. That's going to be the number of cations is equal to 4. You could proceed through with that. The last little piece of the puzzle, I guess, that I should mention is always, always, always remember that this lattice parameter here, which is going to be the basis for your calculation of the volume of the unit cell, is equal to 2 times the radius of the anion plus 2 times the radius of the cation. Don't fall into the trap of thinking that the anions touch across the face. I'll in fact write that in. The anions do not, touch sorry about that, touch along face diagonals. They do not touch on face diagonals, as they do for FCC. So sometimes when we explain rock salt, we'll look at the blue ones there, for example, just looking at the blue ones. You say, oh, that looks like FCC. Yes, it's FCC positions, but remember, they can be pushed apart by the presence of the cation. It pushes them apart so they're no longer touching one another. But the cation is always, always, always touching its nearest neighbor anions. And so that means that this cation here, for example, will be touching those 6 nearest neighbor anions. Thanks a lot.